Hey YouTube, well I'm sick and I'm home today, so I wanted to make a little video, and this video will be on genetics, and starring, like, the father of genetics is Gregor Mendel. Now there's a big story behind him. He used to work with pea plants, and he had tall pea plants and small pea plants, and he cross-pollinated them, was crossbreeding them, and he got all tall plants. So he knew that he had one dominant gene, and he didn't know what happened to the small gene. So what he did was he bred the offspring together, and he got some small plants, and he's got some tall plants. So that's basically it. He found out that one gene was recessive, which this applies with leopard geckos. Now, that's just some background on the history. Now, there's a bunch of different genetic traits that came out, and first off, I'm going to talk about snows, like the Mack snow gene. Alright, so first off, here, I'm just going to move this so that we get that out of the way. First off, the Mack snow gene is a codominant trait, and yeah, so basically, this is how it goes. If I breed a super snow, which, come here, girl, here's a super snow. SS means super snow. If I breed a super snow to another super snow, I will get 100% super snows. SS means super snow. But if I breed a Mack snow to a super snow, here's a Mack snow and here's a super snow, I will get 50% Mack snows and I will get 50% super snows. If I breed a Mack snow to another Mack snow, I will get 50% Mack snows, I will get 25% super snows, and I will get, here, hold up, I'm just going to rotate over, and I will get 25% chance of getting a normal. There's a baby normal. That's probably a normal. So, yep, 25% normal. But if I breed a Mack snow to a normal, so this gecko right here, Mack snow, sorry for the shakiness, to a normal, which is in here, to a little normal, I will get 50% normals, and I will get 50% Mack snows. Basically, the Mack snow gene is codominant, so it means whenever you breed a Mack snow to something, a regular Mack snow, which is this, you'll get half Mack snows. But if you breed a super snow, which is the super form of it, which is, it's a super snow, you'll get 100% Mack snows no matter what you do. It's just one way of proving that you'll get Mack snows. So, yeah. And if you breed a super snow to a normal, you basically get 100% Mack snows. So that's really cool. Some neat little stuff right there. I wanted to go over a codominant trait. Now, not all virgins, like, of codominant traits have it. Actually, yeah, codominant traits do have a super form. I'm not sure about that. But I know for, like, supergiant works the same exact way. If we have a supergiant, bred to a supergiant equals 100% supergiants. There, if you guys want to look. The SS means super snow. The SM equals Mack snow. And normal equals normal. So those are the ratios that you could be getting hatchlings if you bred them. So that's kind of cool. Now, in Mendel's reasoning, I'm going to move on to recessive genetics as well in this video. So yeah. So anyway, there is a gene called a recessive trait. Now, a recessive trait is something like the Tremper albino. It basically means when you breed a pure, meaning an animal that physically shows the phenotype, which is, let's say, Tremper, where it has an albino in it, that is the phenotype. It physically shows it. That's called a pure in genetic terms. And basically, what happens is, let's say we have a pure, so a pure is always represented with little a's, and let's say we have a normal leopard gecko, which is represented in big A's. What will happen is that we'll move down, the big letters always go in front of the little letters, and this is showing that it carries, all the offspring will carry the pure's albino. So all these babies will be het for albino, and in this case we're going to say Tremper albino. Alright, I'm just going to grab our eraser out. So then what we're going to do, as I could have left that A, we're going to cross the offspring together. Alright, so now we have big A, little a, crossed to big A, little a. Sorry, that's a, little a. Alright, so anyway, we're going to get one big A, and this is a pure normal. This is a normal, that's a carrier. Whatever the big letter has in front of it, that means it's dominant, so this is what the phenotype will show. This is just the genotype. The genotype shows that this is a carrier, and I'm going to explain that in a second. And then we're going to get one pure out of this. So, out of 4 babies, only one should be a pure for the albino gene. But 2/3 of the normals will carry the albino gene. 1/3, which in this case is AA, will be a pure normal. And there's no way to tell because visibly all 3 of these combinations will all look like normals and you can't tell. That's why when you buy geckos, like, here I'm just grabbing the Super Snow. When you buy geckos, there's always pos hets unless it was bred to a pure. So basically what a pos het, a 66% pos het is we're breeding a het to a het. And that's basically what it is. But your chances of the gecko that you buy that's a 66% het, because figure this, it's always 1/3. So 1/3 of 100 is 33. Alright? 2/3 is 66. 3/3, which equals 1, is about 99. That's how it kind of goes. I mean, there's always those .333 repeating decimals, but that's basically what we are showing you with 66% of a het. So basically, if we want to breed now this, a het to a pure, what's going to happen is these markers are dying on me like left and right. If we breed a het to a pure, we're going to get, no matter what, the babies will all be hets, and we're going to get half pures. So here's a Tremper albino, here's a Tremper albino, here's a carrier, which is a normal, but het for Tremper albino, and a normal het for Tremper albino. And that's kind of how the genes work. I'm going to try to get out of Gecko and show you what I'm meaning for hets. Like right here, here's a gecko that is het for Tremper albino, and this gecko is also het for Blizzard. I'm not going to go into double hets unless you guys would like me to do a separate video on doing double hets genetics, but yeah. So I'm just going to put back these geckos real quick. Alright, but these geckos are het for Tremper albino, and they're also het for Blizzard. But here is a Tremper albino. This is actually a Tremper albino snow, but it is close enough for the purpose of this video. So basically, let's just say that this is a Tremper, it's just a snow and 2. But basically, this is the pure. This shows the phenotype of the gene that you want to display, which is the Tremper albino gene. As these geckos don't show the Tremper albino gene, but they do carry it because their mother, which is also this one's mother, is a pure like her, which visibly shows it. So that's kind of cool. If I bred these 2 geckos together, which I know they can't, but if I did breed them together, I have a 1/4 chance of hitting an albino, and 2/3 of those babies would carry the albino gene, and 1/3 could possibly not carry the albino gene. But, you could have all babies from them, and all of them could really carry the albino gene. So that's also kind of cool. Another thing I want to show you is if you breed a het to a normal. Okay, right? So the AA is displaying a normal. This is showing a normal phenotype, but the genotype carries the albino gene. So what's basically going to happen is we're going to have 50% het albinos and 50% normals. But no matter what, all these babies will look like normals. They'll just, half of them will be het for albino. So half of them will be het for this. So it's just something that's really cool. I've had geckos that I purchased, and they were 50%. Yeah, 50% het eclipse. That's possible, 50%. So it could have it or it could not. And it proved out that every baby that hatched out was an eclipse out of her, and she's not an eclipse. So, she turned out to be the 50%. But, certain genes, from my understanding, I've heard people say the eclipse gene is really easy to pass on, and a lot of geckos pass it on pretty easily. And there's really no error. And, so whenever you buy, a pos het eclipse, chances are that is het eclipse. Your odds are really on your side there. But of course, for one of my geckos that I have, the breeder didn't know that the male was het for Tremper albino, and she bred it to Trempers plenty of times, never produced anything, never produced any Trempers out of it, and then one day, one Tremper popped out, and I own that Tremper. And that's kind of the cool gecko that I have right now that came from a 50% het. I did not breed her, but she is gorgeous. Here she is. She is probably a snow glow het raptor, so that's pretty cool. She's produced raptors before. So, really cool gecko. But again, sometimes they just don't show the genes, and you won't be able to tell out of a first test breeding. It's all just depends on what comes out. And yeah, so that's basically talking about the recessive gene with the Tremper albino. If you guys would like me doing any other things like double Punnett squares, this is a Punnett square right here. But if you guys want me doing more Punnett squares and doing a more detailed version, well, this is kind of detailed as it is, but if you guys really do want me to do another one the Mack nose right here, and you want me to do a Punnett square with the recessive genes or go over a certain gene, let me know. And I would even be willing to do a double Punnett square, which those are hard, but they're easy if you know how to do them. And I do know how to do them, and I would show you even how to do a combination het radar to a normal Abel het radar, which has a het eclipse, blah. Abel het eclipse bred to a normal double het for radar, which is het eclipse and het bell. And I would just go over that if you guys would really like me to. I have no problem with that. Please comment below and tell me your opinion on this video. I thought it was pretty good, but I want to know what you guys thought of it, and give me your personal feedback on what you thought, and if you would like me to do another genetics video. So I hope you guys enjoyed. God bless.